covered with volcanoes. It is tremendously geologically active. There are volcanoes erupting all the time.
Every world in the solar system has its own thing going on, but Io, one of Jupiter's moons, takes the chaos crown. It's packed with raging volcanoes spewing lava into space, while Jupiter looks huge in its sky, sometimes blocking out the sun. The surface is a mix of yellows, reds, and oranges, giving it an otherworldly vibe. Fiery, dangerous, and strangely beautiful. Io is nothing short of a cosmic rebel. How Io was found. Over 400 years ago, back in 1610, Galileo Galilei changed the game for astronomy with a telescope that would probably seem like a toy compared to today's tech. While peering at Jupiter, he noticed 4 tiny stars hanging around the giant planet. These turned out to be moons, and they're now called the Galilean moons. One of them, Ganymede, holds the title of the largest moon in the solar system. Then there's Europa and Callisto, which have gotten a lot of attention for their potential to host alien life. But the closest moon to Jupiter, the fiery and unpredictable Io, was just as fascinating. Galileo named it Io, inspired by a mythological figure, and it didn't take long for astronomers to realize there was something special about this rocky little world. For centuries, though, Io's surface was a mystery. Telescopes weren't powerful enough to see much detail, and we were left to guess what it was like. People assumed it was just another cold, crater-covered rock in space. Boy, were we wrong. Fast forward to modern times, and Io's true nature has been revealed, thanks to better telescopes, space missions, and a whole lot of science. We now know it's one of the most volcanically active places in the solar system. Seriously, the surface is constantly reshaped by massive eruptions that would put Earth's volcanoes to shame. Its composition is wild, too. Sulfur and other elements create its signature yellow, red, and orange hues. Size-wise, Io is no slouch either. It's the 4th largest moon in the solar system, with a radius of about 1,821 kilometers. While it's not as big as Ganymede, Titan, or Callisto, it more than makes up for it with its dramatic personality. If we compare Io to our moon, they're nearly the same size, close enough to call them celestial twins in terms of diameter, but that's where the similarities end. Io is 21% more massive than the moon, making it a lot denser. In fact, it's the densest moon in the entire solar system. Its average density is around 3.5 grams per cubic centimeter, which is even higher than most non-metallic rocks here on Earth. Clearly, something unique is going on beneath Io's colorful surface. So, what makes Io so dense? To find out, we need to dig into its insides, or at least rely on the calculations and models scientists have made. At Io's core lies a compact, dense center made mostly of iron and sulfur. This core is estimated to make up about 20% of Io's total mass, with a radius somewhere between 350 and 900 kilometers, depending on whose numbers you use. But here's the thing, despite its fiery volcanic activity, Io's core isn't entirely molten. Scientists have figured out that the heat generated inside Io isn't enough to fully melt it all the way down to the core. This conclusion is backed up by the fact that Io doesn't have its own magnetic field. If it had a fully molten, churning core like Earth, it would generate a magnetic field. But Io's is almost non-existent. Surrounding this core is a solid mantle that makes up the bulk of Io's interior. About 75% of this mantle is composed of a mineral called forsterite, which is rich in magnesium. Forsterite is a tough, resilient rock that can handle the extreme conditions inside Io, and it helps explain the moon's high density. And here's where it gets even crazier. Io's insides are just as intense as its volcanic eruptions. The solar system's powerhouse, Io's insides are just as wild as its surface. Scientists have calculated that its outer layer is home to a vast ocean of molten magma about 50 kilometers deep. This fiery layer is ridiculously hot, around 1600 Kelvin, or more than 1300 degrees Celsius. Go deeper, and even though the temperature rises, the pressure is so intense that the rock remains solid. Above the mantle lies Io's lithosphere, which is between 12 and 40 kilometers thick. But don't imagine it as a smooth, unbroken shell. It's full of cracks and fractures. In many spots, these cracks are like windows to the molten interior. with lava spilling out to create massive structures on the surface. Here's where Io breaks the mold compared to other moons. There's almost no water ice or frozen gases to be found. Spectral analysis has confirmed that Io's surface is mostly made of borates, sulfur, and a sprinkling of dense minerals. This unusual mix accounts for its sky-high density compared to other moons in the solar system. By the early 21st century, Io's surface had been mapped and studied in detail, thanks to at least 5 automated orbital missions. But the real breakthroughs came in the 1970s with NASA's Pioneer and Voyager probes. These missions sent back jaw-dropping images of Io's surface, revealing massive volcanic plumes erupting with gas and particles. Some of these plumes shot up as high as 500 kilometers, about the distance from New York to Washington, D.C. Before this discovery, active volcanoes were thought to be an Earth-exclusive feature. Io rewrote the rulebook. Scientists realized they were looking at the most volcanic place in the solar system. Those early missions opened up a whole new chapter in understanding moons, planets, and how these extreme environments could work. So, what makes Io so unique? Its fiery personality comes from its location. Io is caught in a gravitational tug-of-war between Jupiter and its fellow moons, Europa and Ganymede. This constant pulling and stretching generate heat inside Io, driving the insane volcanic activity. For the first time in human history, astronomers looked beyond Earth and didn't just see ancient frozen lava flows or long-dead volcanoes. They saw actual active eruptions, and not just any eruptions. These were massive, some even more dramatic than those on Earth. On Io, scientists have discovered around 400 active volcanoes. While that's about 2.5 times fewer than Earth, Io's much smaller size makes it the most volcanically active place in the entire solar system. Its compact area is absolutely packed with volcanic chaos, earning it the title of the ultimate cosmic hotspot. Unsurprisingly, such an extraordinary celestial body has become a prime focus for astronomers. Over the years, exploration missions have gathered a treasure trove of high-resolution photographs of Io's surface. By 2012, these images had been used to create a detailed geological map of the Moon. This map highlights Io's dramatic landscape, including sprawling plains, rugged mountain ranges, lava flows, and its countless volcanoes. One feature that truly stands out is the massive orange-brown ring in Io's southeastern region. Known as the Pele volcano, this vast area stretches over 1,000 kilometers, roughly the size of a large African country. It's one of Io's most striking landmarks, a vivid testament to the Moon's extreme volcanic activity. But what drives all this chaos? Io's volcanic energy comes from its position in a relentless gravitational tug-of-war. Jupiter's immense gravity pulls at Io, while the nearby moons, Europa and Ganymede, add their own forces to the mix. This constant pushing and pulling create tidal heating within Io, keeping its insides churning and its surface erupting. Thanks to these volcanic forces, Io's surface is in a constant state of renewal. Lava flows reshape its landscape regularly, and eruptions create towering plumes that can reach hundreds of kilometers into space. It's like Earth's volcanic activity cranked up to 11 and squeezed into a moon that's only a fraction of our planet's size. The massive orange-brown ring around the Pele volcano is believed to have formed from sulfurous emissions spewed out over time. At the heart of this colossal feature lies the volcano itself, with a massive crater called a Patera. This multi-level cavity stretches about 30 by 20 kilometers and is filled with molten lava, a bubbling cauldron of volcanic chaos. Scientists studying photographs in infrared and visible light found something fascinating. The temperatures across the lava surface aren't constant. They fluctuate wildly, with the hottest spots reaching a scorching 1,300 degrees Celsius. It's thought that the Patera connects to Io's glowing mantle via an underground channel. This channel acts like a lava expressway, keeping the molten rock inside constantly stirred. What's happening in there is pure volcanic drama. Volatile substances trapped in the lava try to escape upward, causing the molten rock to rise. This creates intense pressure under the lake's thin, solidified crust. Occasionally, the crust can't handle it and cracks wide open, triggering massive lava outbursts. And when I say massive, I mean it. Some of these eruptions shoot lava and rock particles over 300 kilometers into space. Imagine standing on Io and seeing glowing sulfur and rock being launched like a volcanic fireworks show. Once these particles are ejected, gravity slowly pulls them back down to Io's surface. Over time, this volcanic rain settles around the Pele volcano, forming the giant sulfur ring that's so strikingly visible from space. It's an ongoing process, constantly reshaping and replenishing the area. What makes Pele so unique is its sheer activity and scale. It's not just a volcano, it's like a natural factory, endlessly churning out lava, gases, and volcanic debris. This process has been going on for so long that it's left a permanent mark on Io's surface, creating one of the most iconic and recognizable features in the entire solar system. But while Io's surface and volcanoes are jaw-dropping, its atmosphere is something else entirely. Io's thin atmosphere and equatorial auroras. Many of Io's volcanoes share similar formations, but the Pele Ring holds the crown as the largest and most striking. However, Io's volcanic activity doesn't just shape its surface, it's also responsible for its thin, unique atmosphere. Io's atmosphere is barely there compared to Earth's. It's mostly made of sulfur dioxide, with its density varying depending on the location. In volcanic plumes, the gas pressure is 25 million times lower than Earth's atmospheric pressure. Away from eruptions, it drops even more. On Io's sunlit side, the pressure is about 1 billion times lower than what we're used to. And on the night side, it's practically a vacuum, trillions of times thinner than Earth's atmosphere. Despite this ultra-thin atmosphere and the fact that Io doesn't have its own magnetic field, it still manages to put on a light show. Yes, auroras have been observed on Io. These colorful displays happen when charged particles from Jupiter's powerful magnetosphere slam into Io's atmosphere, causing it to glow in different hues. Interestingly, Io's auroras don't usually appear near its poles, like they do on Earth. Instead, they mostly show up around the equator. Why? Because the charged particles traveling through Jupiter's magnetic field hit Io at a tangential angle, right where the atmosphere is thickest. The result is a stunning, multicolored glow that's unique to this little moon. So, even though Io's atmosphere is practically non-existent by our standards, it still manages to surprise us with its quirks. As we continue our journey across Io, we head northwest, passing the edge of the Pele sedimentary ring. Ahead lies one of Io's most impressive features, the massive Boosaule mountain range. This mountain range stretches about 540 kilometers in diameter, but the standout peak here is South Boosaule Mons, which towers above the landscape. The base of this giant is about 145 by 159 kilometers in size, and it rises an astonishing 18 kilometers above the average surface of Io, twice the height of Mount Everest. To put it in perspective, the total area covered by this entire mountain range is roughly 18,000 square kilometers. That's about the size of a small European country like Montenegro or Slovenia. It's no wonder that this dramatic landscape has captured the attention of astronomers and explorers alike. The structure and appearance of South Boosaule Mons point to a massive tectonic event in Io's distant past. The mountain is thought to have formed after a significant tectonic cataclysm, where part of Io's crust tilted and sank into the moon's mantle. One side of the mountain remained elevated above the surface, creating this breathtaking peak. The southeastern slope of South Boosaule Mons is especially striking. It's an incredibly steep cliff that drops about 15 kilometers, making it one of the tallest ledges anywhere in the solar system. This towering drop is enough to make even the most daring explorers think twice before attempting a hike. South Boosaule Mons is a peak unlike anything you'd see on Earth. The mountain's towering size and steep cliffs make it a truly unique feature in the solar system. Such formations aren't possible on Earth because of our higher gravity, which makes it harder for mountains to reach these extreme heights. On other planets and moons, the lack of tectonic activity means you won't find anything like it either. So, South Boosaule Mons stands out as an incredibly rare geological wonder. Continuing on our journey, we head northwest, and soon we come across another giant formation, Loki Patera. This is the largest volcanic depression on Io, and it's massive. The chasm is about 250 kilometers in diameter, making it an enormous feature in the landscape. Its total area is over 50,000 square kilometers, which is roughly 1.5 times the size of Lake Baikal, one of Earth's most stunning lakes. But unlike any lake we know, this chasm is filled with molten sulfur silicate lava rather than water. The depth of Loki Patera is truly mind-boggling, extending several dozens of kilometers beneath the surface. This gives it an otherworldly feel, and the sight of the lava slowly churning inside gives you a glimpse into Io's intense volcanic activity. And just when you think things couldn't get crazier, we find ourselves at Loki Patera, home to one of the most fascinating features on Io: Lava Lake. Loki Patera isn't just a lake of lava, it's a dynamic powerhouse connected directly to Io's molten mantle. This connection ensures an endless supply of fresh, fiery material bubbling up from below. The lake's surface temperature typically ranges from -3 degrees Celsius to a toasty 57 degrees C, surprisingly low for molten lava. This cooling happens because Io's thin atmosphere lets the heat escape, forming a solid crust on the lake's surface. But that crust doesn't last forever. Over time, usually between 400 to 600 days, the crust gets heavier as it thickens. Eventually, it can't support its own weight and cracks apart, sinking into the molten lava below. When this happens, waves of molten material rise and flood the surface at speeds of about 1 kilometer per day. After the chaos, the lake settles, and the crust slowly starts forming again, repeating this wild cycle. Despite all this fiery action, Io's surface isn't exactly a haven for life. Key ingredients like water and carbon dioxide, essential for life as we know it, are practically non-existent here. Without these, Io is deemed a no-go zone for biogenesis. Moving on from Loki Patera, we head toward another intriguing area: Media Regio. Could life exist on Io? It's a tantalizing question. While the blistering surface of Loki Patera and other lava lakes seems utterly inhospitable, some scientists have speculated that these extreme environments might harbor unusual forms of life. On Earth, certain hardy organisms thrive in hydrothermal vents and isolated ocean caves, enduring scorching heat and sourcing energy from chemical reactions involving sulfur or iron. If similar life exists on Io, it would need to be incredibly resilient, adapting to high temperatures and chemical-rich conditions. That said, Io's relentless tectonic activity and the extreme temperature fluctuations across its surface make this possibility pretty slim. The harsh conditions would likely be too much even for the hardiest extraterrestrial microbes. Still, the idea of sulfur-loving, iron-metabolizing alien life forms sparks the imagination, doesn't it? But let's zoom out a bit. While Io's towering volcanoes and fiery lava lakes tend to steal the spotlight, most of the moon's surface is surprisingly flat and quiet. These less dramatic regions are blanketed in thick layers of sulfurous sediments, giving them a pale, almost pastel appearance from space. Among these vast plains is Media Regio, a standout feature on Io's map. Located west of the volcanic powerhouse, Loki Patera, Media Regio is an irregularly shaped, bright region that spans an enormous area. Measuring about 2,600 kilometers in diameter, it covers roughly 12.6% of Io's total surface. That's no small feat for a moon known for its chaotic geology. The region's smooth and relatively uniform surface sets it apart from Io's rugged uplands and volcanic hot zones. Surrounding Media Regio are towering mountains and scattered volcanic pits, adding contrast to its otherwise serene appearance. This makes it a fascinating area for researchers, as it represents the quieter side of Io, a stark difference from the planet's more volatile regions. While Media Regio might not boast the fiery drama of Loki Patera, its expansive, sediment-covered plains tell a quieter, yet equally intriguing story about Io's geological history. While Media Regio might seem like a relatively calm and uneventful part of Io, it's anything but boring. Most of this massive region is smooth and uniform, but scattered lava flows from nearby volcanoes have left their mark, cutting through the otherwise serene landscape. What makes this area so fascinating is the incredible thickness of the lithosphere beneath it. Scientists think it might resemble the Earth's continents, offering a rare glimpse into Io's ancient geological stability. This thickness likely explains why Media Regio has held onto its integrity for so long, standing firm in a moon defined by chaos and volcanic activity. There's another intriguing theory about this region. Some researchers propose that Io's upper mantle in these quieter areas isn't as molten as its volcanic hotspots. Instead of a reservoir of liquid magma lurking beneath, Media Regio might be sitting atop a patchwork of partially melted mantle fragments. This lack of tectonic activity has essentially given the region a geological chill pill, allowing it to remain relatively unchanged over time. But don't let its calm demeanor fool you. Media Regio is also a testament to Io's wildly contrasting environments. Unlike the fiery volcanic regions, this area is cold. Like, really cold. The surface temperature of Media Regio hovers around 110 Kelvin, or a bone-chilling 163 degrees. That's hundreds of degrees cooler than the blistering lava lakes and volcanic pits elsewhere on the moon. At such low temperatures, sulfur dioxide from Io's thin atmosphere doesn't stay airborne for long. Instead, it settles onto the surface as frost, creating a smooth, icy coating across the plains. This frost gives Media Regio its unique color palette, a dazzling mix of yellow, red, and black hues that stand out in stark contrast to the rest of Io's rugged, fiery landscape. Now, let's take a step into one of Io's most surprising features: its frozen plains. Heading northwest from the smooth, frosty plains of Media Regio, we stumble upon another of Io's fiery marvels, Amarani. This isn't just another random volcano on this volcanic wonderland of a moon. It's one of the showstoppers. Amarani is a massive, lava-filled rift in Io's crust, but its real claim to fame is the drama it brings to the surface. At first glance, the volcano's crater, or caldera, might not seem all that impressive, with a diameter of just 37 kilometers at its widest point. But don't let the size fool you. Amarani's real spectacle lies in what surrounds it. The volcano is encircled by a network of enormous lava flows, making it a standout feature even when viewed from space. These flows, dark and stark against Io's brighter sulfur-coated plains, are what make Amarani impossible to ignore. The largest of these lava flows stretches a jaw-dropping 300 kilometers north and spans up to 60 kilometers in width. This flow isn't just big, it holds the title of the largest active lava flow in the solar system. Another impressive flow heads westward for 250 kilometers, making it almost as noteworthy. For a while, scientists thought this second flow was a separate formation, but closer inspection revealed that it, too, is a part of Amarani's volcanic handiwork. But Amarani's artistry doesn't stop there. To the east of its main caldera lies a collection of smaller, dark lava streams. Their unique color suggests they're composed of silicates that melted and later solidified, basically frozen rock rivers, adding even more complexity to this volcanic giant's resume. Amarani also boasts a fascinating internal structure. Beneath the surface, magma tubes likely snake through the region, occasionally bursting to cause eruptions far from the main rift. These hidden magma pathways are a testament to Io's intense geological activity. Io isn't just a moon. It's a volcanic powerhouse that puts every lava-spewing mountain on Earth to shame. Among its most fiery hotspots is Tashar Pai, a sprawling region of volcanic chaos in Io's northern hemisphere. Spanning about 300 kilometers in diameter, this area is a stage for some of the most spectacular volcanic shows in the solar system. The region isn't just a random cluster of volcanoes. Tashar Pai hosts several volcanic calderas, all likely fed by a single underground magma source. These interconnected systems mean eruptions. Here aren't your typical spurt some lava and call it a day scenarios. Nope. These are monumental, awe-inspiring, borderline apocalyptic events. Take, for instance, the eruption that rocked Tashar back in 1999 to 2000. This wasn't just a bit of lava bubbling up. This eruption blasted volcanic material a mind-blowing 385 kilometers into space. That's like launching a volcanic plume higher than the International Space Station's orbit. The fallout from this event spread over an area with a radius of more than 700 kilometers, blanketing Io's surface in fresh volcanic deposits and likely making some alien geologists very excited. But that wasn't the end of Tavashtar's fiery saga. Fast forward to 2006, and the region experienced another cataclysmic event. This eruption lasted a whopping 530 days, nearly a year and a half of continuous volcanic activity. Imagine living next to a volcano that erupts non-stop for that long. The plume from this event reached an impressive 330 kilometers in height, once again hurling thousands of tons of sulfur and silicate lava into Io's thin atmosphere and beyond. So, what powers all this volcanic madness? Io doesn't have the internal heat reserves we're used to seeing in planets, which come from the radioactive decay of elements in their cores. Instead, Io's energy comes from a gravitational tug-of-war with Jupiter and its neighboring moons, Europa and Ganymede. As Io orbits Jupiter, the gas giant's immense gravity stretches and squeezes the moon, generating heat through friction deep within its interior. This tidal heating keeps Io's insides molten and fuels its relentless volcanic activity. The results are both mesmerizing and chaotic. Io's surface is constantly being reshaped by eruptions, and the low gravity lets volcanic plumes soar into space. Some of this material falls back onto Io, but a lot of it escapes entirely. Particles from Io's eruptions contribute to a diffuse cloud around the moon and even help form parts of Jupiter's rings. Some particles settle on Jupiter's other moons, creating a solar system-wide splash zone. Let's dive into what makes this moon the most fiery, energetic place in the solar system: its volcanic power. The solar system's volcanic powerhouse. Io, Jupiter's volcanic moon, is a celestial oddball that keeps scientists on their toes. Tavashtar, Loki, Amarani. Its landscape is like a who's who of the most dramatic volcanic hotspots in the solar system. And yet, even with all the excitement it offers, Io doesn't get the same VIP treatment as some of its icy neighbors like Europa or Ganymede. Why? Because Io's hellish surface isn't exactly screaming potential for life. But hey, it's still fascinating as heck. In early February 2024, NASA's Juno spacecraft swung by Io, zipping just 500 kilometers above its surface. Think of it as a cosmic flyover tour. Juno beamed back a collection of stunning images showing massive chasms, soaring volcanic plumes, and rivers of molten lava. The kind of visuals that make you go, wow, nature's metal. These close encounters help researchers learn more about Io's composition and atmosphere, especially through potential future spectral analysis. What's in Io's thin air? What's in its molten depths? Questions like these drive the ongoing fascination with this moon. Now, you'd think Io would have its own dedicated mission by now, right? It's literally the most volcanically active body in the solar system. But nope, while we've sent probes to Jupiter and its moons, Io has to share the limelight with Europa, Ganymede and Callisto, moons that might have water and therefore a chance at harboring life. NASA had once toyed with the idea of a mission called Io Volcano Observer to study Io's fiery landscape, but it never got off the ground. Instead, missions like Europa Clipper and JUICE focus on the icy moons, leaving Io to bask alone in its fiery glory. It's a shame, really. Understanding Io's volcanic activity could reveal a ton about tidal heating, a process that could be happening on other moons or even exoplanets. Still, Io's chaotic surface and epic eruptions continue to capture our imaginations. Its volcanoes, erupting on a scale Earth can't compete with, offer an unparalleled view of planetary processes. Even if Io's scorching surface isn't home to life, it teaches us about the forces that shape moons and planets across the cosmos. What do you think? Leave your thoughts in the comments below, and if you liked this video, don't forget to subscribe to our channel. See you in the next one.